Okay, hello guys. Today we are talking about gradients and tangents. Okay, so moving to the first part of it. So first, let's see the graph. Like here it said y equals to x cubed minus 8x plus 7. Here it has a gradient equals to 4, right? So here we can find the problem is how to find the 2 points at the tangent equals to 4. Okay, so as we already know that we have to first find the differentiation of it, right? So for x cubed minus 8x plus 7, we can first find the differentiation for it. So dy over dx equals to 3x squared minus 8, okay? So once it equals to 4, we can say x squared equals to 4. So x equals to 2 or negative 2, okay? So we can say that the 2 points obey the rules for that the gradient equals to a constant value 4, okay? That is it. And then you can put x equals to 2 and x equals to negative 2 into the two curve for this, okay? So when x equals to 2, we can say y equals to 2q minus 8 times 2 plus 7. The value here is 8 minus 16 plus 7, it equals to negative 1. Okay. So also when x equals to negative 2, we can set here the y value can be considered as negative 2 cubed minus 8 times negative 2 plus 7. So finally the value becomes 15. Okay. So we can set that the 2 points here is for 2, negative 1, and negative 2, negative 15. Okay. That's the 2 points on this. Okay. So here you can find there's a graph for this. And here's negative 2, 15, and 2, negative 1, okay? And also here, so we have said, if we have a point with a given gradient, first we have to find the differentiation for that is dy over dx. And then you can set, then find it equals to the constant value for the gradient, and then find what exactly x value is, okay? Okay, so here's the exercise for you. So let's just try to see it together. Like the problem is that y equals to x squared plus 4x minus 3, right? And where the gradient is negative 2. So you can set here that first trying to make a differentiation about it. So that here is for 2x plus 4, okay? 2x plus 4. And then we can set when it equals to negative 2, so x equals to negative 3. Okay, so that is for the differentiation for this, right? And also because that here, if there's greater than negative 2 and problems, because that the answer we can find that negative 3 and just put negative 3 into it. So it's negative 3 squared plus 4 times negative 3 and then minus 3. Okay, that is it. So you can find it's negative 3, negative 6 for the final problem. And also for here, if the gradient equals to 3, you can first try to find the coordinate or find the differentiation about this, or if y over dx equals to 3 times x squared minus 6x and minus 21. So when the gradient equals to 3, we can find the value is 3x squared minus 6x minus 24 equals to 0, right? So you can divide it by 3 on the two sides. That is for x squared minus 2x minus 8 equals to 0, okay? And you can set here, like, just divided negative 8 into negative 4 and 2. So it's x minus 4 times x plus 2 equals to 0. So here, x equals to 4 or x equals to negative 2. Okay? So then just put 4 and negative 2 into the value. You can find here that is negative 2, 2, and 4, negative 88. Okay? That is for the gradients and tangents in the problem. Okay. And also, let's move to the next part about increasing and decreasing functions. So here's the two definition about that. So first, because the increasing function means like dy over dx bigger than or equal than 0. Okay, so that is for the increasing function. So for example, like the functions has always increasing, that means also the like the differentiation for this also becomes a positive value. That is for increasing function, right? And when here it is decreasing, that means here dy over dx is smaller or equal than 0. So that is for all the y value. Okay. Okay. So for example, like here, the problem set shows that y equals to x cubed plus 4x, that here is an increasing function. So first of all, we can say trying to find the differentiation of it. So that is for dy over dx equals to 3x squared plus 4. Okay, that is for dy over dx. That is a positive value always, right? Because 3x squared is bigger or equal to 0. So 3x squared plus 4 is bigger or equal than 4. Okay, so because here is an increasing function, right? Okay. So maybe for the second problem to show that 1/3 times x cubed minus 3x squared plus 9x as an increasing function. So you can just try to find the differentiation of it. So it's dy over dx equals to x squared minus 6x plus 9, right? So you can find here, you can just using the rules a minus b squared, that is a squared minus 2ab plus b squared, right? So you can find here, the value here is x minus 3 squared, okay? So it's bigger or equal than 0. So we can say here, because it obeys a rule, so it's an increasing function of that, right? Okay, that is for this problem. And you can find here, like these are two increasing function, we have already proved that, right? And you can find here, it finds also part of it is increasing and the differentiation is also or always bigger than 0, right? Okay. And here is also some exercise for you. So you can just try yourself and just do it. But if you want to follow with me, you can keep on going, okay? So maybe for the first problem, y equals to negative x cubed is a decreasing function and scatter graph. So first, we can say the dy over dx is the differential of the y, right? It equals to negative 3x squared, okay? So this value you can find is smaller than 0, right? Because it's negative 3x squared. X squared is smaller than 0, bigger than 0. So negative 3x squared is smaller than 0, right? So that is a decreasing function. And for second problem, y equals to 1 cube, 1 over 3, or 1/3 times x cubed minus 2x squared plus 5x. So you can first try to differentiate it. Okay, so it's dy over dx, that is for x squared minus 4x plus 5. Okay, that is it. And you can find, oh, maybe to prove it is an increasing function, you have to set maybe that is bigger or equal than 0, right? Because x squared minus 4x, you can add it a 4, that is for x minus 2 squared plus 1, right? So you can find it's bigger or equal to 1. So that here is an increasing function, right? Okay, but that is for the problem here. Okay. And also we can use another notation for this. Like here you can set this fx differentiation, okay? So you can set that f, here it is, and also it equals to dy over dx, okay? That is it. So for example, like fx equals to x cubed plus 2x squared minus 3x plus 1. So first you can set the differentiation for x is f dot x, here is for 3x squared plus 4x minus 3. Also, you can just written that as dy over dx equals to 3x squared plus 4x minus 3. Okay, that is it. Okay, and also here's a problem or examples like how to find the gradient and tangent. So also the problem is that find the equation of the tangent where x equals to 2 on the curve. So first you can try to find the differentiation for it. That is f differentiation of x. Here is for 3x squared and minus 4x and plus 3, right? So here, when x equals to 2, you can just to put x value into it, right? So it is 3 times 2 squared minus 4 times 2 plus 3. So that is for 3 times 4 is 12. 12 minus 8 and plus 3 is 7, right? So we can say here the gradient for it is 7, okay. And x equals 2 means here x is 2 and y value can be calculated as 2 cubed minus 2 times 2 cubed squared plus 3 times 2 minus 4, right? And you can find the value here is 8 minus 8 and plus 6 minus 4 is 2, right? So it passes through the point 2, 2, and the gradient is 7, so you can say y here equals to 7x plus c. So just put 2, 2 into it. So it's 2 equals to 7 times 2 plus c. So c can be calculated as negative 12, okay? So finally, the function can be written down, or the gradient or the lines can be written down as y equals to 7x minus 12, okay? So that's for today's our lesson. Hoping you can all understand about gradient and tangent. So it's very important part in our A-levels levels. Okay, so let's move into the next part. So see you next time. Bye.